Hello students. In second year, you all will be having a technical subject in your syllabus. Out of this subject, one is the thermal engineering. Thermal engineering is one of the major subject in mechanical engineering. First will we see what is the thermal engineering. Thermal engineering is a specialization subdiscipline of mechanical engineering and chemical engineering that deals with the movement of heat energy and transfer. The energy can be transferred between two mediums or transferred in a form of energy. The thermal engineers will have a knowledge of thermodynamics and the process to convert a generated energy from thermal sources into the chemical, mechanical or electrical energy. Thermal engineer must allow the proper amount of energy to be transferred for correct use. Some components that a thermal engineer could work with include heat exchanger, heat sinks, radiator and many more. Some systems that require a thermal engineer include boiler, heat pump, water pump, engines and many more. In this thermal engineering, we cover these topics. First, fundamentals of thermodynamics. Second, ideal gases and gas process. Third, steam and steam boiler. Fourth, steam turbine. Fifth, steam condenser. Sixth, heat transfer and heat exchanger. In first topics, today we discuss on working substance, pure substance, thermodynamic system, types of system, difference between open, closed, isolated system. Let us see what is pure substance. A substance that has a fixed chemical composition through its mass is called pure substance. Example, air is a mixture of several gases, but it is often considered as a pure substance because it has uniform chemical compositions. Then, working substance. A substance which is capable of absorbing and rejecting heat during the process is called a working substance. Example, petrol engine working substance is mixture of air and petrol. One more example, in air compressor working substance is air. Next term, thermodynamic system. The term system is defined as a specified region where the transfer of energy on mass are to be studied. Then boundary. The envelope enclosing the system, which may be real or imaginary, is known as a boundary of system. And the boundary may be fixed or moving. Then surrounding. The region outside the system is known as a surrounding. Then universe. When the system and surrounding put together is known as a universe. This is a basic diagram of system and surrounding. In this diagram you see system, boundary and surrounding. System means it is specified region where a transfer of energy or mass can be done. Boundary, it may be real and imaginary surface. Surrounding, the region outside of the boundary is known as the surrounding. Universe, all are put together is known as a universe. This is representation of system, boundary and surrounding. In order to understand the concept of system, boundary and surrounding, consider a piston cylinder arrangement as shown in figure. In this case, there are three fixed and real boundaries formed by the inner surface of the cylinder and one movable boundary formed by the bottom surface of the piston. The gas constant in cylinder enclosed by the boundaries in the system. All the matter and the space external to this boundary is known as a surrounding. There are three types of system. First, closed system. second open system, third isolated system. These three systems I will explain you with example. Closed system. In this system, only transfer energy but no transfer of mass across the boundary. Example, piston and cylinder arrangement. Let us see this example in briefly. The closed system shown in figure, in which gas is enclosed between piston and cylinder. The mass of the gas is constant within the system even though the gas may be compressed or expand because it is closed from the all sides. Thus, there is only transfer of energy take place across the boundary of the system. Open system. In this system, both transfer of mass as well as energy may cross the boundary. Open system can be explained with the example of turbine shown in figure. In turbine, both mass and energy transfer take place. Such open system is described with the help of the control volume and control surface. Isolated system. In this system, when no flow of heat, work and mass take place across its boundaries. Example, this is a daily use example, thermoflash. Tea present in a thermoflash. In this, heat and mass of the tea cannot cross the boundary of the thermoflash. Hence, the thermoflash is isolated system. Let us see comparison between open system, closed system, isolated system. In open system, first point is mass of the system do not remain constant. In closed system, the mass of the system remain constant. In isolated system, the mass of the system remain constant. In open system, second point is it can be explained with the concept of control volume and control surface. In closed system, it can be explained with the concept of boundaries. And isolated system, it can be explained with the concept of the boundaries. In open system, third point is in open system, mass as well as energy may transfer across control volume. In closed system only energy transfer across the boundary of the system. In isolated system, mass and energy do not transfer across the boundary of the system. So let us see the example of these three systems. In open system, example is steam turbine, steam engine, compressor, IC engine, condenser, etc. In open system, piston and cylinder arrangement without a wall. In isolated system, gas enclosed in insulated vessel.